Okay, what we're going to do here today is we're going to talk about factoring using a method we call the X method. So in the X method, I'll take each of these that I'm going to factor, and for example, for this first one, I will just go ahead and I'm going to draw an X here. And in that X, I'm going to use two things. I'm going to put in the product, which will be this 10, and the sum, which will be this -3. So for the product, we will go ahead and label this as P for the product. Let's just go ahead and do it in a different color here for you. And then this will be our sum. So for the product, we put in -10. This is our product. Our sum is going to be -3, this coefficient. So let me get these out of the way real quick. And now, again, the product is what we're going to use here to find two numbers that multiply to be -10, but then add to be -3. So let's start. Let's go ahead and take a guess. Let's find two numbers that multiply to be 10. Don't worry about the negative. We'll put the negative on each one. So, for example, if I chose 1 and 10, I can multiply these. I can make the 1 either negative or the 10 negative and multiply to get -10. But when I add them, no matter which one I make negative, I cannot add those to get -3. So this combination doesn't work. Well, let's try 2 and 5. Okay, 2 and 5. 2 times 5 is -10. Can I multiply 2 and 5 to get, or can I add 2 and 5 to get -3? Well, looks like we can. And how can we do that? If I made the 2 negative and the 5 positive, these multiply to be -10, but they do not add up to be -3. So instead, I'm going to have to make this, we'll go ahead and let me erase that down here. We're going to go ahead and make this a -5, and that a +2. And so now if I put 2 here, -5 there, I can multiply these two to get -10, and I can add these two to get this -3. So those are the factors. So we're going to say x plus 2 times the x minus 5. And that's the solution to this. Let's do the second one over here in the same manner. I'm going to go ahead and make my x to start off, and I put a big X here, and I'm going to find the product and the sum. Again, the product is going to be this value right here. This is the product, and then the sum will be this value. That's the sum. So let's go ahead and put in the product of 18 and a sum of -9. And the goal, again, is to find two numbers that multiply to be 18, but then add up to be -9. So let's go through the process, and we'll choose some numbers here. Okay, let's see. If I choose x, or if I choose 1 and 18, if I multiply these two, I get 18, but I can't add these two in any way to get -9, so that doesn't work. Let's try 2 and 9. Okay, 2 and 9 gives me 18 when I multiply, but again, I cannot add up these two in any way, no matter which one was negative or if they both were negative, to give me -9. So let's try 3 and 6. Okay, 3 times 6 gives me 18. 3 plus 6 gives me 9, but I need a negative. So I need to make this a -3 and that a -6. So -3 times -6 gives me what I need. -3 times -6 gives me +18. -3 plus -6 gives me -9. So this factors into x minus 3, x minus 6. And you can always check each one of these. How do we check? We FOIL them out. If I were to use the FOIL method, first times first, x squared, outers, that would be -6x, inners would be -3x, and then last, plus 18, I get this answer. So remember, factoring is the opposite of what we do when we multiply out with FOIL. Okay, let's try the next one. I have a product, again, of 4, and here a sum of 5. All right, let's try to find some numbers here. So if I try to find two values, let's say 1 and 4, and I multiply these out, will I get 4? Yes. Can I add these and get 5? Yeah, that works. So 1 and 4. That one was easy. It was our first guess here. So x plus 1, and then x plus 4. Again, these you can always double check this by foiling these out. All right, let's try the last one. We have a product of 12 and a sum of -7. Let's see what works out here. Okay, we can always start with the basics. Again, let me highlight these again. This is the product right here. That's the product. And this is the sum right there. That's our sum. Okay, so let's just try some numbers. 1 and 12. Can I multiply these to get 12? Yes. Can I, any way, shape, or form, add them to get 7 or -7? No. Okay, how about 2 and 6? Yes, they multiply to be 12. Can't get 7 out of them. How about 3 and 4? Okay, they multiply to be 12. Is there a way to get -7 out of this? Yes, if this was a -3 and that was a -4, then -3 times -4 gives me 12. -3 plus -4 gives me the -7 I'm looking for. So that's my answer, and this becomes x minus 3 times x minus 4. And that is the solution to this problem. Thank you for watching, and I'll be posting up more later. One final note. The key to these is that this coefficient in front of the x squared, let's do a different color for that one, has to be a 1, okay? That has to be a 1x squared, a 1x squared. Anything other than 1x squared, and that won't work with this method. We would have to employ another method, a two-step method. First we could use the x, then we'd have to do factor by grouping or any other technique. I will be posting that in another video, so make sure to look for the video on factoring when the coefficient in front of the x squared is not a 1. Thanks again.